Hello! This week's maths challenge is all about scale. On this slide, you can see that scale has lots of different meanings, and we're not talking about your bathroom scales or scales on an animal. We are talking about the type of scale that you see on a map and is used to show when things are a lot bigger or a lot smaller than they are in real life. Your task is going to be to draw an item in your house to scale. And on this picture, I have drawn a 50p coin, and my scale is 1 centimetre in real life, was 5 centimetres on the picture. So I've made it 5 times bigger, and I'm going to show you how to go about that, drawing things bigger or smaller to scale. So once upon a time in the classroom.
For this lesson, you might use a measuring stick and a ruler. A quick recap on measurements. There are 100 centimetres in a metre, and there are 10 millimetres in a centimetre. The millimetres are the really small ones that you can see here, smaller than my fingernail. The centimetre is about the width of my finger. Reptiles have dry, scaly skins? Scales? Not that kind of scale. Scale is to do with ratio, proportion, and how much bigger or how much smaller something is. We say times bigger or times smaller. We often see scale on maps. On this map of Ireland, for example, we can see that the scale is 1 centimetre on the map is the same as 20 kilometres on the ground. That means in real life. And we would write that like this, using a colon. 1 centimetre on the map is the same as 20 kilometres in real life. On the map, you can see that from Tralee to Killarney is about a centimetre. That means that in real life, you'd have to drive 20 kilometres. From Dublin to Wicklow is about 2 centimetres. So, what would that be in real life? Have you worked it out? So, to get from 1 centimetre to 2 centimetres, we multiply by 2, and we have to do the same on the other side. 20 times 2, 40 kilometres in real life. From Waterford to Rosslare is about 2.5 centimetres. Let's see if you can try and work out what that would be in real life. So if we know 1 centimetre on the map is 20 kilometres in real life, and 2 centimetres on the map is 40 kilometres in real life, what's half a centimetre? Or 5 millimetres in real life? Would be 10 kilometres, half of 20. So 2.5 centimetres on the map would be 50 kilometres in real life. That's 2 centimetres plus half a centimetre, 40 kilometres plus 10. You often find the scale of a map at the bottom.
When we think of ratio, we think for every something, there are something. If you look at this picture, there are 2 squares to 4 circles. For every 2 squares, there are 4 circles. And that is a ratio of 2 to 4, and we use a colon in the middle. 2 squares to 4 circles, 2 to 4. Now, just like in fractions, these can be simplified. And if we divide both sides of the colon by 2, we get for every 1 square, there are 2 circles. And that is a ratio of 1 to 2. 2 squares to 4 circles and that can be simplified to 1 to 2. Now it's very important that we think about the direction and the order that we write these numbers in, because they matter. There are not 4 squares to 2 circles. There are 2 squares to 4 circles. When we think of proportion, we think of out of something there are something, and here out of 6 shapes altogether, 4 of them are circles. We write that like a fraction, 4 out of 6. And once again, this can be simplified. Out of 3 shapes, there are 2 circles. So out of these 3 shapes here, 2 of them are circles. Now, keeping things in proportion, this is going to be important when you do your task today. You can see that I've made the star bigger. Now, if that was to be 2 times bigger, you can see that the star has not changed shape at all, and the ratio of its width to its height stays the same, and it just gets bigger. So if it's getting 2 times bigger, we have to multiply the length, the height by 2, and also the width by 2.
So your task is going to be to draw an object in your house to scale. I'm in the classroom right now, so I'm going to use this table. The table's height is 72 centimetres. Now the table's width is 60 centimetres. And the table's length is 1 metre and 20 centimetres. 1 metre 20, that's 120 centimetres. So I've got my measurements written down, my real life measurements, 72 centimetres, 60 centimetres and 120 centimetres. Now I want to draw these on a piece of paper, so I need to make them several times smaller, and I need to do the same to all the measurements to keep them in proportion. So my scaled down measurement, I'm going to divide by 10. 72 divided by 10. Decimal point would be here. I'm going to move the numbers around the decimal point and make it smaller. 7.2 centimetres. 60 centimetres, it's easy to divide that by 10. 6 centimetres. And 120 centimetres, 12 centimetres. So my scale here is in real life for every 10 centimetre, my scale measurements divided by 10 is 1 centimetre. Now, I don't have any measuring equipment at home, so to draw this, I might need to use some unconventional measurements. I might use my hands and measure it in hand spans. I might use my feet. I might use my fingers. There's many ways that you can measure if you don't have a ruler at home. But try to draw straight lines when you're drawing.
You are going to draw a scale drawing of something in your home. You will need something to draw with, and something to draw on. Here I've got a piece of exercise equipment that I have made 2 times bigger in my drawing, and I have used my finger widths to measure that. First things first, measure each dimension, whatever you're measuring it in. Remember that you don't have to use a ruler. You can use finger widths, hand spans, foot lengths, book lengths, phone widths, depending on what it is that you are measuring. Pick a scale that fits on your paper. You might need to check how wide or how tall your paper is first to decide what scale will fit. You might want to then make it smaller than in real life or bigger. For example, if you're drawing an eraser from your pencil case, you're going to want to make the scale bigger. You're going to want to make it 2 times, 5 times, 10 times bigger than in real life. But if you're doing your bed, you're going to be wanting to make it smaller. Make a table so you can make each dimension bigger or smaller by the same amount. Here is an example. This is from the school table with the real dimensions, and I've divided them all by 10 for the drawing because my scale is 10 centimetres in real life is 1 centimetre on the drawing. It is 10 times smaller. Have fun!